Hello and welcome to Akademi Ekonometri. In economics course, in the previous video, we covered the opportunity cost and the margin analysis. Today, we will continue our lecture with week 1 part 2 video. In this part, we will try to first understand what kind of decisions we are making in a given economy. Then, we will try to understand the process of production, the inputs, outputs, and then finally, I will try to explain you what is a given economic model, what are the conditions of an economic model, and finally, we will create our first and simplistic model, which is called Production Possibilities Frontier. Let's start the course, and let's start from the decisions that we have to make in a given economy. In a given economy, generally, we have to answer or we have to decide on three different topics, three different points. The first one is what will be produced? What kind of goods or services do you want to produce? First of all, you have to give a decision on that. And the second one is how are you going to produce these goods and services? These two decisions are generally really important. The third one is to whom will it be distributed? You produce the goods, services, and you decided how to produce these goods and services. And finally, after they are produced, you have to decide how to distribute these goods and services. Generally, in modern capitalist economies, the first two decisions are really important. But unfortunately, the third one is generally disregarded. Now, let's talk a little bit about the process of production. In the simplistic form, the process of production is you put some inputs and you combine it with the technology and the production process, and finally it yields outputs. Let's start with the inputs. We divide here the inputs to 4 different parts, but generally we only use, in this class, we only use labor and capital to make our job and model simplistic. So the first kind of input is labor. It is the workforce that you spend or you use when you go to work. Capital is the second one. When I say capital, you need to think or you need to imagine about the factories, buildings, roads, machineries that you use in the production process. It might be cars and trucks. The third one is the natural resources. When I say natural resources, these resources are the resources that we collect from our motherland, world. So they might be metal, they might be wood, they might be even water. The third one is entrepreneurship. Entrepreneurship is kind of a logic or your idea, your imagination to use labor, capital, natural resources and combine all of them with the technology and create a output, goods and services. Without the entrepreneurship, you cannot even do the production process. So entrepreneurship is really important. And then you use these inputs and combine with the technology, even low or high technology, in the production process. And this production process yields outputs. When I say outputs, you need to understand 2 different kinds of outputs, which are goods and services. When I say goods, these are concrete or explicit things that you can hold. These are not abstract. So basically they might be cars, TVs, couch, chairs, glasses, every kind of not absolute things, concrete things that you can imagine. But when I say services, you cannot hold it with your hands, but you can see the service. For example, you ride a bus, right? You step on a bus and you ride a bus and someone is riding that bus, driving that bus. So basically that bus driver is giving you a service. In the production process, he uses his labor, he uses the capital is the bus itself, and then combines it with the technology and entrepreneurship, and at the end of the production process, he gives you his service. So when I say outputs, you need to understand not only the goods, but the goods and services both. I can give one more example to services. For example, you go to a coffee shop. In the coffee shop, a person is serving you, a bartender is serving you. So the good that the bartender gives you is actually a service. Just forget about the coffee, but also he's bringing you your coffee, so that's kind of a service. He's using his labor. So the end result is you have to understand goods and services when you hear the word output. The next topic we are going to cover is economic models. Economists use models to understand the complex real-world economy. Our real world is really complex because it has a lot of different variables that can affect the end variable that we are going to analyze. So that's why we need models. And models are actually the simplified versions of the reality. So we take the complex real world economy or the complex reality, and then we use some assumptions in the models to simplify it. And the models are considered good if they predict the actual complex real world accurately. So accuracy is really important. The other aspect is in a model you have to use assumptions because it's a social science and you cannot control everything at the same time. And as long as these models predict the real world accurately, we will call these models good models. An economic model is a means of explaining how a sector of the economy functions. In a simplistic model, consists of three different parts. The first one is economic variables that I will explain in a moment. The second part is assumptions. Assumptions are really important for an economic model because economics is a social science, and in social science we have a lot of different variables that can affect our analysis. So we must hold some of them constant, or we need to do some assumptions to make our model simplistic enough to analyze. And the third part is the implications. The implications are actually what does this model say? What's the results? What do we get from that model? That's that part. And economic models are the abstractions that use logic to establish cause and effect relationship among economic variables. So our ultimate aim is to find a cause and effect relationship between the target economic variables we are trying to analyze. So the main assumption we use in economic models generally is the ceteris paribus assumption. Ceteris paribus is a Latin phrase which means other things being equal. In this assumption, we examine a change in one variable but hold all other variables constants. In this way, this assumption allows us to isolate the effect of a single variable. To elaborate this idea, I will try to create a simplistic economic model with three different variables. Let's say we create a model, and in this model we don't know the details of that model, but I know that the model has two different arguments, and these arguments actually X and Y are actually some economic variables. Let's say this is inflation. Okay, and then let's say we have the other economic variable, and let's say this is GDP, gross domestic product. And in this model, this is the closed form model. We don't know the details of that model. We don't know the parameters, but at least we know that the X is affecting Z and Y is affecting Z also. So we also know that X affects Y and Y affects X. So forgive my simplistic model, it might be true or not, but just to elaborate what does ceteris paribus mean, we will assume that way. So here, what we are trying to understand in an economic model, we want to understand what does happen to Z when I change X. Let's say when I change X, when I increase X. When I increase X, what happens to Z? And I want to know what happens to Z only, but only X increases. So, but at the same time, I know that when I change X, the Y is going to change as well. And at the same time, I know that when y changes, it's going to affect z too. So there will be some indirect effect, which is coming from x to y and z. So I want to isolate. I want to isolate only the effect of x. I don't want the indirect effect of x, which is coming from y to z. So basically, if I have to draw it, I want the effect of this one, but I don't want this effect. I don't want this kind of effect. So that's why when we are using economic models, we generally tend to say that when I change x, let's say increase, the y is constant. It's not changing. Even if there's a relationship between x and y, we don't want that. And holding y constant, I only try to want to see what happens z. That's the way we can isolate the effect of x on z. That's why we use ceteris paribus condition. And it's a really important condition that we use in most of the economic models. So speaking of which, we were talking about the economic models. Here is our first economic model, and it is called production possibilities frontier. First of all, let's try to define the production possibilities frontier. Production possibilities frontier is giving us the combinations of outputs that a society can produce if all of its resources are being used efficiently. So this efficiently words actually is coming from using all of the resources. And when I say resources, you need to understand the nature resources and also the technology. So it's kind of a frontier, it's kind of a border, and it tells you how the maximum amount that you can produce, and it gives you all of the combinations of the maximum amounts that you can produce. When I show you production possibilities frontier on a graphic, you will understand that better. So for now, let's try to understand the assumptions of that model. In that model, we hold technology fixed and we hold resources fixed. And to make our model simplified enough, we will use only two goods, and we will do our analysis by using these two goods only. And we don't have prices, we don't have markets, we are only talking about the production. We only care about the production, and we only care if you doing that production efficiently, inefficiently. That's what we want to know right now. So in a simplistic production possibilities frontier, as I said, we have two different goods. In this example, we have pizza on y-axis, and we have wings on x-axis. And right now we have a constant slope PPF. I'm going to use PPF abbreviation for production possibilities frontier. So we are going to have two different kinds of PPF. This one is a constant sloped PPF, and later I will show you a bow-shaped PPF. It has a different aspect. We are going to cover that, but for now, let's focus only on the constant slope PPF. On a constant slope PPF, we have some arbitrary numbers. So this point A, which equals 100, shows that the maximum amount of pizza that this country can produce with given resources and technology. And also, this country, if this country uses all of the resources and the technology in the wings production, this country can produce 300 wings and 0 pizza. So basically, the point A and point B are showing me the extreme points that this country can be on the production possibilities frontier. Can we own some points between point A and B? Yes, sure we can. So let's pick two more points. Point C is actually still on the production possibilities frontier. If we stay on point C, that means we are using all of the resources and the technology, but we are producing a combination of pizza and wings at different amounts compared to point A and B. On point C, we are producing 70 pizza and 90 wings. And on point D, we are producing more wings than before compared to C, and less pizza compared to before, compared to point C. So basically, point A, C, D, and B is on the production possibilities frontier line, and that means we are using all of the resources and the technology. As you can understand from its name, production possibilities frontier is kind of a border. It shows you the best you can do, or the combinations of best production points that you can make by using all of your resources and the technology. So basically, if you use all of your resources and the technology, you can be on any point on the line this is drawn here. So you can be on a point here, on a point here. It doesn't matter. As long as you're on the point, that means you're using all of the resources and the technology. That's why if you're using all of the resources and the technology, that's why we call that these points are the efficient points. Why this is called, these points are called efficient? Because you're using all of the technology and the resources. There's no leftovers. Can we produce inside of the production possibilities frontier? Yes, we can. That's also possible. So take point F as an example. On point F, this country is producing 40 pizza and 70 wings. Basically, that's possible. Yes, this country is producing, but the problem with this point is an inefficient point. It is inefficient because there are some leftovers in the resources and the technology. Because this country, by using all of the resources and technology, can be better off from moving point F to point A, C, D, or B, or any point on the line. So that's why all of the points, if the country is producing inside of that line, we will call these points are inefficient points. Can the country produce outside of the production possibilities line? For example, a point on a point like E. Since this country doesn't have enough resources and the technology to go beyond that line, the country cannot produce at point E, on point E. It is not possible without specialization and trade. In the next video, I will try to explain you the specialization and the trade, and with these two terms, a country can produce anywhere on this line and can do the consumption out of the production possibilities frontier. So that's why for now, since we don't have trade and the specialization in our simplistic model, for now we will assume that this point E is unattainable point. We cannot reach that part right now. So why is the production possibilities frontier downward sloping? The reason is, let me turn back to the graphic. So the question was, why is this line downward sloping? Remember, downward sloping has a negative slope. Downward sloping lines has a negative slope. So that means if you want to increase the production of one good, you have to decrease the production of the other one. For example, if you start from point A and move to point C, we have to decrease the production of pizza to increase the production of wings. That's why we have a downward sloping production possibilities frontier. We have to make a choice. Remember, our resources are fixed. Our technology is fixed. That means resources and the technology are scarce. There's a scarcity concept we have to think of. That's why you have to make a choice. And if you are making the choice, we have to talk about the opportunity cost. When the opportunity cost involves in our analysis, that means you have to, if you want to do or if you want to produce one good more and more and more, that means you have to face off with a cost. And the cost I'm talking about here is you have to give up production of the other good. I'll try to explain that in a moment, but first let's finish the slide. Why are we unable to produce certain combinations? It's because of the scarcity and the limited resources. I emphasize on that several times. Since we have two important assumptions in this model, fixed resources and the fixed technology, that means we have to face off with the scarcity and the limited resources. So we cannot produce on this point E here. So the next part is efficient points. We covered that one. Point A, B, C, D are the efficient points. Any point on the line should be efficient points. Inefficient points are you are not using all of your resources. That means you are inside of the line, not on the line. So that's why we call this point inefficient points. So here you have one more sentence here. Workers going off unused buildings. So unused buildings is really easy to understand. If you are not using all of your resources, of course you have to be on a point like F. But how about workers going off? Workers going off means unemployment is increasing in that country. Let's turn back to the graphic. Let's first imagine that the country is producing on point C. On point C, that means this country is using all of the resources because it's an efficient point. That means this country is using all of the labor resources as well. And to make our job easy, let's assume that we have 100 workers in that simplistic country, in that model. And suddenly, 20 of that workers are unemployed. Let's imagine that one. So that means if that country is only using 80% of the labor force, that means this country is not using all of its resources. That's why the country moved from point C to point F. The production possibilities frontier will stay intact. It's not going to move. Because remember, production possibilities frontier is showing you what you can do best or what you can do at the best. So it's kind of your benchmark. This is what you can do, but you can be on a point like F. That's possible. So on point F, we have unemployment. And let's continue our story. Let's say the unemployment level was 20% on point F. Let's say after the economy grows, these people find job and there is no unemployment in that economy again. If this is the case, if the unemployment is decreasing in that economy, again the country will move from F to point like C or D or B or A. So the country will continue to produce efficiently again. Unattainable points are points outside of the PPF. So I said for now, because after we add the trade and the specialization, we will see that these unattainable points like E will be available, will be attainable. We will see that in the next week. So production possibilities frontier, and now we will combine it with the opportunity cost. First of all, let's try to recall opportunity cost. It was the highest valued alternative. So you pick one action and the cost of picking that action should be the highest valued alternative. What we give up as a result of an action. Opportunity cost, in this case, is the slope of the production possibilities frontier. But the main question is, for which good of the opportunity cost we are talking about? Is it the opportunity cost of pizza or the opportunity cost of wings? So first of all, we have to understand that one. But to calculate the opportunity cost, we can use slope. Because as I said, opportunity cost is, in this case, is the slope of the production possibilities frontier. So First of all, I will try to explain you how we find the slope in a given constant linear line. So I'm going to use the same numbers that I gave you in the slides. On the y-axis, we have pizza, and the maximum amount was 100. On the x-axis, we have wings, and the maximum amount is 300. And we have a straight line, a linear line. We know that the slope is constant on linear lines. And to calculate the slope, we can use the slope formula. Usually, people use change in the rise over run, or change in y divided by change in x. And we will define slope as m. So I know that the point here is 0 by 100. And I know the point here, this point was A, this point was B. Point here is 300 by 0. So what I'm going to do is, I'm going to use this formula and calculate the slope, first of all. So I will find the change in y. The first y is 100, the second y is 0, so the difference is 100. The first x is 0, the second x is 300, the change is negative 300. So the slope is negative 1 over 3. Let's save it here. And now let's try to calculate the opportunity cost. And here, let's imagine we want to move from point A to point D directly. So basically, this country can either produce 100 pizza or 300 wings. To produce 300 wings, this country is giving up 100 pizza. So basically, since we are producing more wings, we can calculate the opportunity cost of producing wings. Why we are talking about the opportunity cost of wings? Because we are moving from point A to B. We are producing more wings and less pizza. That's why we have to talk about opportunity cost of wings. So that's why I will use this equation. Opportunity cost of 300 wings equals 100 pizza. So what I will do is, I want to find out the opportunity cost of producing 1 wings in terms of pizza. That's why I'm dividing these numbers, these two numbers, by 300. So what I will find is, opportunity cost of 1 wing is 1 over 3 pizza. As you can see, the value we find here is actually the absolute value of the slope. So since the slope of this line is constant, the opportunity cost of producing more wings is going to be always constant. It doesn't matter if we move from point A to point B. We can move from point A to C. Still, the opportunity cost of producing more wings will be 1 over 3 pizza. If we move from point C to D, again, the opportunity cost of producing more wings will be 1 over 3. Same thing applies when we move from point D to B. Now we calculated the opportunity cost of producing 1 more wings, but now I want to calculate the opportunity cost of producing 1 more pizza. In this case, I want to move from point B to point A, because since I want to talk about the opportunity cost of producing more pizza, I have to produce more pizza and less wings. And the value that I'm going to find will be in terms of wings. So I know that if I move from point B to A, I will produce 300 wings. I will produce 100. Let's write it like that. I will give up 300 wings. This is what I give up. And instead, I will produce 100 pizza. So basically, opportunity cost of 100 pizza will be 300 wings. That's what I give up. So to make our numbers simple enough, I will divide these values by 100. So opportunity cost of one pizza here will be 3 wings. As you can see, this value is actually the inverse of the opportunity cost of producing one wing. So basically, that's just the inverse. And I know that at the same time, the value we find here is just the absolute value of the slope. So basically, our end result is the opportunity cost of producing one wing is always constant. Since it's always constant, opportunity cost of producing one more pizza is always constant, and it's always 3. So if I move from point B to point D, opportunity cost of producing more pizza is 3. One more pizza is 3. If I move from point D to point C, opportunity cost of producing one more pizza is again 3 wings. It doesn't matter if I move from point B to A, point B to D, D to C. It's always same and it's always constant. This result is actually happening because we have a linear production possibilities frontier. The slope is constant if we have linear production possibilities frontier. One more important thing that you need to remember about the linear production possibilities frontier is in this kind of production possibilities frontier, we don't have the specialization. We don't have it. What does it mean? What does the specialization mean? Specialization means that some of our resources are specialized in producing one good or the other one. For example, we have some, let's say in a realistic country, we have some Italian chefs and we have some chefs which are really good in producing kebab. So these people, these chefs are really specialized in producing some products. But in this simplistic example, when we have linear production possibilities frontier, we don't have this specialty. We don't have specialization. So basically, if you pick, for example, we have 100 chefs in that given country. If you pick one of them, this person will be really good in pizza production, and he will be really good in mixed production as well. So he's not specifically specialized in producing either one of the good. He can produce pizza and wings with the same efficiency. But that's not really realistic, so we will try to expand our model and we will try to use a production possibilities frontier which has specialization. And in this case, we will draw PPF like a bow-shaped PPF. In a bow-shaped PPF, we will have the specialization. Because why we are adding that dimension to our model? Because we want to make our even simple model as realistic as we can make. So let's continue our slides. We can draw a more realistic PPF by making it nonlinear and bowed outward, as I explained to you here. Our intention is to make our model more realistic, and if you add that realistic dimension to our model will no longer be linear model or linear line. Instead, we will have a bow-shaped line. So the PPF will not have a constant slope in this case. Let's try to cover the slope in this case. For example, we move from this point A to point B. Remember, in the constant slope case, if we move from point A to point B, the slope is same, opportunity cost is same. Same thing applies if you move from point A to C. Let's see if this is going to happen in a nonlinear PPF. So to understand the slope, we have to write a tangent. So let's say if we move from point A to point C here, the tangent will be around here. If we move from point C to D, the tangent will be here. As you can see, the slope is increasing. If you move from point D to B, the tangent will be around here. So basically, the slope, when you move from point A to point C to D to B, the slope is increasing. Remember, in the previous example, when we have a constant slope production possibilities frontier, we relate the slope with the opportunity cost. So we are going to do the same thing, but we know that since the slope is changing, slope is when we move from C to D to B, slope is increasing. That's why the opportunity cost will increase. So that means we have pizza on the y-axis, we have wings on the x-axis. Since we are moving from point A toward point B, we have to talk about the opportunity cost of wings. So basically, when we move from this point A to point B, the opportunity cost of producing one more wings is always increasing. And that is the law of increasing relative costs, actually. That's the idea of the law of the increasing relative cost. Let's turn back to slides and cover some text parts. So we said that the production possibilities frontier will not have a constant slope in this case, and we relate that to opportunity cost. The slope will get steeper as we move from left to right, and opportunity cost will not be constant. We covered that part, and in the previous graphic we moved from left to right, but I didn't move from right to left. It's going to be the same. If we move from right to left, the opportunity cost will not be constant and it's going to be increased again. But in this case, if I have to show it, what I will do is this time I will try to move from point B to point D. As you can see, the slope is getting smaller and smaller and smaller. Instead of slope is getting smaller, I will say that the opportunity cost of producing one more pizza is still increasing. And the reason is, remember, when we have a linear PPF, we try to understand the behavior of producing one opportunity cost of one more pizza with the inverse absolute value of the slope. So we will do the same thing. We will take the inverse. As you can see here, when we move from point B to D, the slope is getting smaller, but we will take the inverse of it. So instead of getting smaller, the opportunity cost of producing one more pizza will get higher and higher. And we will relate that conclusion with the law of increasing relative cost again. So, law of increasing relative cost, it refers to the increasing opportunity cost of production that occurs as you move along the production. So, it basically means that if you produce one of a good, let's say you want to produce more of good A, and if you produce more and more and more of that good, you have to give up increasingly larger amounts of good B, the other good. This is what we had in the pizza and wings case. If you want to produce more and more and more wings moving from point A to B, the opportunity cost of producing one wings is always increasing. Same thing applies if you move from point B to point A. Let's now try to see that idea, see that logic in the graphic. So right now we are moving from point D to C to B and to A. And in each part, we want to increase the pizza production 20 points. So when I move from point B to C, I'm increasing the pizza production by 20. But how much I need to give up in wings production? It's 30 points. Again, if I move from point C to point B, I'm increasing the pizza production by 20, but this case, I am decreasing the wings production by 50. The cost of producing 20 more pizza is increasing. Here in this case, when I move from point B to point A, again, I am increasing the pizza production by 20, but since I am moving more along the PPF line, this time I have to give up 80 wings to produce 20 more pizza. And this is actually the law of increasing relative cost. If you want to produce pizza more and more and more, in each step, at each step, you have to give up more and more and more wings. Let's turn back to text again. There are some important information that you need to know. The intuition of nonlinear PPFs is resources are not perfectly homogeneous. That means that some inputs are better at pizza making than other inputs. That means we have a lot of chefs in that given country, and some chefs are really specialized in pizza production, and the other ones are really specialized in wings production. If you want to switch a chef who is specialized in wings production and put him into pizza production, this chef will not work as efficient as he was working before. So that because of that efficiency lost, we will say that there is an increasing opportunity cost, which relates to the law of increasing relative cost. As we expand pizza production, we will use the inputs that are the best. But if you want to expand the pizza production more and more and more, what you need to do, you need to take some chefs which were already employed in wings production, but they are not good pizza producers. So you have to use them, and this will cause the efficiency loss. And today we are coming end of the week 1 topic. In the next week, we will try to understand the shifts in the PPF, production possibilities frontier, and then we will add the trade dimension to the production possibilities frontier model, and we will try to understand how trade makes nations wealthier than before. Thank you for watching Akademi Ekonometri. Please remember to subscribe to the channel, like the video. I'll see you next week. Bye-bye.